Yeah, so I guess we could start off. I guess Golden is coming back.
She's coming back. She's just taking Jim quick.
So just while we're waiting for Golden to get back, she's just taking Jim out to get a cab. We sort of outline what the game plan is going forward. So this afternoon, I'm going to give a short talk about one of the challenges of sort of modeling disruptive trade policies, give a little bit of sense about model structure of these trade models, review sort of what the possibilities are. We have a framework that is a sort of a Mellet style framework that we're working on developing. And that'll be just general thing about what comes out of the models, what structure, way to think about how the structural factors of the model have important impact on the results. And then at that point, we're going to take a break for an hour and a half.
Yes.
And so that means from 2 to 3:30 Central, we have a break. Goldman is basically gives a chance for people who want to follow along with the homework, the exercises we distributed this morning. You're welcome to do that. This is the time for you to work on those two exercises. One is the Chauvin-Wally model, and the other is the Miller-Spencer model. It's an opportunity for you to sort of dig in and see what you understand, what you don't understand, and then we'll get together at 3 o'clock and have a chance to go through 3:30 to get a chance to go through and see how we're doing, and that'll be a short session. We'll have half an hour, 45 minutes, from 3:30 on, just to solicit questions and go through things. I can go through the programming here for you, but I think there's a lot to be said for people actually coming forward with their own questions about how stuff works. And no question is too stupid. It's like at this point, it's a matter of get to stage one.
Yeah.
Going forward, then tomorrow the shift is we're going to pivot to the WinDC GTAP framework. So we have this newly developed database that captures U.S. states within an international trade model, and the idea is to do some simulations related to border carbon adjustments in that setting. And so that's largely tomorrow will be related to learning about GTAP, learning about how to think about carbon abatement policy measures in these models, do some simulations that talk about how to represent decreasing returns to scale functions. There's a number of things that we haven't really covered yet that we have to go through, how to handle permits and so forth. So that's our main objective tomorrow, is to go through that. And it's an opportunity for people to put in their 2 cents on what issues they think are interesting. So I'm hoping to have opportunities for people to have a discussion, because this is something going forward. I generally like to do things that are interesting to my client and also are publishable. So that's my main objective here, is to think about that. And we just finished a survey piece on border carbon adjustments for nature climate change. I don't see in the literature, I don't see a lot that's been done about the heterogeneous effects across US states. And I think that that's an angle that definitely is interesting to look into. So it's a chance for us to sort of talk about climate policy and trade. And I'd love to get Converse's input on this, things you guys are interested in.
Yeah, other things, yeah.
And then we come to Friday, and Friday I'm open to different conversations about what we want to do. We have to finish up I have a 1 o'clock faculty meeting, so we have to finish up on Friday morning, but I'm open to suggestions. One thing I was thinking about is how to use the WIOD database. The WIOD is this international input-output database that Jim mentioned in his talk yesterday. I have a version of that in GAMS. We could talk about how to do that and to calculate things like embodied carbon content or embodied value added. You can look at value added content of China by product in the US. I mean, so a variety of things we could do in that framework. So I'm open to suggestions about how what we do on Friday morning, but that's, if I don't hear anything from someone, that would be my default, would be to talk about how to work within the WIO framework on the thing. It'd be nice to go. I mean, Jim brought up a lot of intriguing ideas about multinationals, and we had this sort of worked a little bit on his monopoly mode choice model. I talked a little bit about that this morning. So there still are interesting things there. It's just that stuff is not quite ready. One thing is to get the framework ready where you're able to just apply it, and the other thing is to develop the right framework. And Jim's really good at the former, like how to get the right ideas together. It's important. So if I don't hear anyone on on the web. I don't know.
Is there something
Yeah,
in the chat?
Natalie just confirmed with everyone the schedule
Yeah.
and translated it into Eastern time.
Okay, okay.
Perfect.
So that's the game plan. So the game plan is just we have a half an hour, 40-minute talk now, take a break, pick up at 3:30, 45 minutes, start again tomorrow morning at 9 o'clock, get done by 12,
Perfect.
declare victory.
Yep.
That's the game plan. Okay.
Excellent.
So today, let me just see if I can get rid of this hide.
Yeah.
So we'll talk a little bit today about general equilibrium modeling of trade. And this was a paper which we started a couple of years ago. When we were working with the Brits we developed some models in the finance ministry at the UK. Christoph Bohmer and I were looking at economic impacts of Brexit. And in the context of that, that was kind of interesting. And the whole idea there was they wanted to know, there was a lot of interest in what the range of impacts are. They don't want a point estimate. They want to know how do assumptions translate into different results. The idea was not, they were sufficiently moxie to know that it's not just one number. You need to know, most interesting answer to any question in economics is it depends, right? So how do results depend on the model structure? And so along comes with Trump, we had a lot of trade policies that were kind of crazy, and there was a lot of call for ex ante assessment of these things. At the time, there was a lot of sort of, I think, misguided claims that once these policies were in place, we'd learn to regret it. We didn't know that there was going to be such disruption going forward that there was no way to determine what's caused by the policy and what was caused by COVID or any other policy. So it's ex post, ex ante, you still have to have some sort of assessment of what these factors were. And that's what this was a paper we developed to try to highlight the frameworks that we had worked on within HMT. And it was a conference was organized with Tony Venables and some other colleagues from the University College London, this framework. So unfortunately, I'm a little bit unhappy because now I look at this paper. This was a good paper. I think we got referees reports back from a top journal, and we didn't get it resubmitted. So this is a paper that sort of I need to get back to get finished. It's like so so I'll talk a little bit about the structure, and this will give us a chance to get introduced a little bit to the things we'll talk about tomorrow. So there are pervasive economic arguments in favor of free trade. So lots of people. It's an article of faith among many economists, but there's this wave of sort of nationalist political movements. They're moving the other direction these days, and so theoreticals require a reality check to contribute to the debate. In other words, we have a theoretical argument: free trade makes sense, but show me, right? So show me what the costs are in a model that's calibrated to the world as we see it. That's the challenge. And are the downside costs as great as we've always asserted them to be? So if you think about what are disruptive trade policies talk about, and I should say that the paper for this is up on the website as well, so you can go back and read.
I send it through the chat.
Okay,
They
so-
have the lecture
okay.
notes and the paper.
Okay, so escalating tariffs. You think about U.S.-China in 2018, Smoot-Hawley in 1930. Underlying logic is one or other trading partner sees the current division of gains from trade as unfair and wants to renegotiate. There also are policies that are more narrowly protective, right? So this is sort of strategic rationale. China is concerned about food security. You might think about energy security as a long-standing concern in the U.S. Policy questions is, what is the value of being more self-sufficient in one or another product? It's like this is a sort of a risk-return trade-off here. And then the other thing is bilateral trade deficits. Like, we look at on a bilateral basis of how much we're importing or exporting from one or another country. When collectively it doesn't really matter exactly who we have the bilateral deficit for. It doesn't really matter. It's all that matters to macro is like what's the aggregate debt. But this is something that becomes important, and we've seen it arise many times within the U.S. policy, sort of political debate. So what we're going to do here is to try to take stock of what happened, and this was at the time we were writing the paper, sort of updating the model every 3 weeks, right? So there's always a different set of of sort of tariff negotiations. And Ming-Chao Lee was a colleague at Iowa State at Ed Ballesteri's postdoc, who basically compiled and was consistently sharing these JTAP compatible. So you get these proposals for tariff actions, which are at the HS6, HS8 level, and then you have to map them back to understand what's happening in the framework of GTAP. So I'll talk a little bit about what is GTAP and how do we put these guys together. And for our purposes, we are, we're looking at countries that are affected by steel tariffs: Brazil, Argentina, South Korea, and basically, there's a variety of other types of factors from these data that we can use in the model. So here we have a diagram that sort of gives us a sense about, on the one hand, we have a blue line point that represents trade flows and import tariff rates. So we get a sense about the goods that are most heavily imported and subject to the least protection are EEQ, that's electronic equipment, other manufacturing equipment. So these are within the other manufacturing goods, OMF. We have leather projects, wearing apparel, textiles, which tend to be more protected, but are not quite as large. So this gives you a sense about the trade between the US and China. And the red line represents sort of what the trade war impact would be on those sectors. If we take the trade elasticity, it's a simple calculation based on the bilateral trade elasticity that's implicit in the GTAP. That's not a full G calculation, it's just a partial equivalent calculation of what do we expect to happen in terms of the magnitude of the volume of trade and the prices of those goods. And we can see that the electric equipment and other manufactured goods are the ones that are most heavily affected. On the other hand, we have a number of goods that are exported from the US to China that are facing more, we're facing sort of protectionism. And so this shows trade flows in the GTAP database in billions along the horizontal axis, and we see what the import tariff rates. And we can see that China has somewhat higher tariff rates, and there's the number of sectors, chemicals, rubbers, and plastics, and these other manufactured goods, motor vehicles. OSD, I think, is an agricultural sector. So you can see what the main sort of factors are that the US is exporting to China. Likewise, then, if we look at US tariffs on steel, and this is one of the things that was sort of a centerpiece at the early stages of the Trump administration, was this idea they're going to bring back steel by putting tariffs on imported steel. And we can see here what the main trading partners are. ROWs, rest of world, but Europe, Canada, other OECD countries, Mercosur, Korea, Mexico. You can see all the sectors, and of course, the US has basically a very, very small tariff on these things. We see our tariff rates rising to 15 or 20% on their imports coming in.
What is MRC?
Mercosur, that's going to be Brazil, Chile,
Okay.
Argentina. If you look at the full data set,
Tom?
you get a lot of a range. You can see that Mercosur is dominated by Brazil, but you can see the range of the products. There's always this trade-off between how much dimensionality you get, what's the returns from being. So we're working with a data set that has, well, I'll be more careful about the model. So if we think about, is this beneficial? So the claim on the Trump administration was that all these policies were not going to cost the US anything because the tariffs are way below what the optimal level is. Let's just bring the US back to let's recenter trade to a level where we're able to extract proper terms of trade. And this goes back to our.
There's a question in the chat that for some reason they're having trouble sending us noise. But anyway, question in the chat for Tom.
Maybe I'm just.
Question from Natalie. You can see the chat as well.
I think I may have turned off my.
Oh, volume.
Maybe I need to get that. Let me just see if I go here and
I
say,
think this is just tariffs.
oh, it should be,
No, that's fine. The question is about something technical.
okay.
Natalie is asking, did you incorporate the 232 quarters at all, or just the tariffs? The 232 quarters.
So this is just tariffs.
So whether quotas,
232 quotas.
yeah, this is mentioned back earlier on. So we aggregate these data for the scope for these countries negotiated exemptions to the tariff: Brazil, Argentina, apply to voluntary export VR equal 15% on an ad valorem basis.
Ah.
I'm not sure the pre-existing quotas, rents, I can't remember. I
Okay.
think that we're using the
I
GTAP.
missed that second bullet. Thank you.
Yeah, I think that we did take into account the ones that were converted to a VER. So, yeah,
And the timeline for the trade flow.
so these are all on an annual basis in the GTAP database.
Okay.
So that's on an annual basis. You can see $8 billion rest of world. If we look at within the full database, Canada has the largest, $6 billion. Brazil has around 3.5. Korea, China, Mexico, Japan is largely specialty steels, around 2.5 to $3 billion. So the basic sort of assertion here is that there's a terms of trade gain that will exceed the dead weight loss. If the tariff goes up, there's going to be an optimal tariff. And then as the tariff gets higher, then it goes up, then it comes back down. So anywhere, but for any tariff between, B and B prime, you're going to have welfare gains come from the tariff. And then at some point, there's going to be a prohibitive tariff where trade goes to zero and economic costs are higher. So this is the basic sort of, textbook model. This was from Feenstra's book textbook. So if we go to GTAP, so I'm looking now at the GTAP database, we could ask, what is the actual gains from trade? What are the gains from optimal? What's the optimal tariff look like in GTAP for the USA? So here we have two lines, and this is one of the things I'll talk about tomorrow. Is that one of the cool things about having a database is that you can then construct a couple different models from the same data. And here we have one model that implements a small open economy model for the US, and that essentially assumes that the terms of trade are fixed and there's no change in the price, relative price of imports and exports. And the other is one where we have a global multi-regional model. GMR model is one where prices are endogenous. So we can see that, okay, so there's going to be an optimal tariff that peaks at around, if you look carefully, it peaks at around 5%, but it's very flat. So the gains in the GTAP database, the gains from optimal tariff. Now, this does not investigate, and again, we'll talk tomorrow about how to do these calculations. It's actually not that hard to compute optimal tariffs in a model where if you've got the equilibrium conditions well specified, then you can optimize over top of them and say, endogenize, you just introduce variables in the model to represent what the tariff rates are and say, maximize this welfare choosing these tariff rates. So that's it's actually not that, it's just a nonlinear program, because if the equilibrium, now it gets harder if the equilibrium conditions are true complementarity conditions where you don't know what quotas are going to be binding and so forth. That gets to be harder. But if everything's a smooth nonlinear system, then it's very easy to do. And furthermore, once you can optimize one country's tariffs, then you can very easily solve the Nash tariffs by just iterating. And it turns out that the diagonalization works really nicely. You maximize the US, you maximize Japan, you maximize the EU, you just go around the circle, and that tends to converge very rapidly. So it's actually not that hard to look at the Nash tariff. If we look at, again, this is the Chinese database. This is GTAP 2000, GTAP 9, 2011 base year, or is it 2014? I think it's 2011. So I haven't done this. It'd be kind of interesting to redo these calculations in the most recent data set. So we have a new data set for GTAP 10A that just came out. That's 2017. So I'd be curious to see what's happened. But in the the GTAP 9 database, China is beyond its optimal tariff, right? So its tariff rate on average is around 5%. So that's the trade weighted average. And whereas the optimal tariff would be around 2.5%. And that's in the multi-regional framework. That's the black line. The red line is the open economy model, which shows that there's going to be a optimal tariff. Basically, it's going to be something that's in this setting. There's a set of other taxes interacting, so it actually doesn't go. There's welfare gains even if it's subsidized imports. So there's a difference here for China. There's a much bigger difference between the GMR, that's the global multi-regional model, and the SOE model. And in the multi-GMR model, it takes into account terms of trade, the optimal tax rate is around 3.5–3%. And this all comes from the GTAP and GAMS paper, which we published in 2016. That's the paper, and all the code for this is available on the website at the JGEA. So how does GTAP work? And I apologize for this diagram because it's not that easy to see, but let's just go through the logic of the model. And this is one of the ways that there are different ways for representing an equilibrium model. Economists or CGE modelers like to use stick diagrams, and flowcharts are our favorite tool. You don't get caught up in detail. So here, if we think about in GTAP, we have the box Y that represents production of goods and services. Box C represents final consumption. Box I represents investment. Box G represents public expenditure. And then we have this box M that represents aggregation of imports. So in this setting, we have exports from other countries come in and get aggregated at the border to form M. And then the imported goods then go along and they are delivered to government, to investment, to final consumption, and to production as intermediate inputs. The domestic production goes out to exports, so that's the arrow going out of the line, or it goes back into domestic demand for domestic goods as intermediate demands within Y itself. That's intersectoral flows, or it could go into final consumption by households, to investment or public expenditure. And finally, over here, we have the final demand, which represents these two boxes, households and government, with one separate within each region. Government buys goods from the government sector. Household buys goods. It makes investment decisions. It buys final consumption. It provides factors of production. Some of them go directly to the sectors. So there's going to be a market for labor that's across all sectors. But then there's also are going to be resources and land and so forth, which gets allocated across sectors within perfect transformation. So that's this factor transformation that's allocating goods. So this is basically what GTAP is about. And we have one such box for every region of the model. And the whole idea of the GTAP database is to be rich on detail and to produce a database which has good coverage, reasonable coverage across most of the market economies in the world. So it has like 120 something regions, and it has around 59 sectors. So it has lots of sectors. That's going to be more sectors and regions than you can solve in one go. But the way we handle that in practice is we typically work with an aggregated model initially in a project, get everything running in that framework, and then we can disaggregate to identify things that we want to know more about. So typically my preference is typically to work with all the GTAP sectors if I can, and then choose the number of regions I can manage. Usually for static models, that means about 25 regions and around 60 sectors are doable. That's a pretty good sized model. So it's about 50,000 equations. So it's pretty good, and it takes some time to solve. But these days, computational power is increasing, continues to be increasing. So I'm finding that I still am more limited by my attention span to detail than I am by the numerics. So here are the 57 sectors that we have. Now, when we're interested in linking GTAP to WinDC, which we have this linked database, and to do that linkage, we have to aggregate away from the 57 sectors. So we have to go down to something where we have to get these guys composite. And tomorrow I'll go through the details of exactly what sectors we have to choose from. So we can't pick from all 57, but this says the number of them. So we build a model. I've already talked about two different types of models, the GMR and the SOE. So we have a model that's endogenous global, and we have one that's a small open economy framework. And now we're going to bring in a couple different other models, and we're going to talk about the standard CRTS model, the Armington model, and then the Melitz model. And the Melitz model is one that it incorporates heterogeneity of productivity across firms in the sector. So in the Melitz model, you have this sorting that goes on that basically causes firms that tend to be more productive, tend to be more involved in international trade. And so therefore, one of the mechanisms you get in the Melitz framework is liberalization of trade. In principle, encourages the production of exactly those firms that are most efficient. So there's this overall dimension. We can see that in the Melitz model, where we have trade is more valuable, we can see the optimal tariff is going to be around minus 6%. So in that case, you might want to subsidize exports, maybe optimal. Again, that's one of the things I should just point out is that the you move away from a CRTS model, you move to an IRTS framework, then suddenly the dominance of laissez-faire goes out the window. You no longer have necessarily market outcomes which are going to be inherently optimizing. So there's always going to be this, when you bring in something that basically can lead to bigger welfare gains from liberalization, that also could be that you're also bringing something in that's going to benefit from strategic government involvement. So there's this trade-off there. It means the model has to be. So let's talk about applied trade policy analysis. So this goes back a long ways. The homework set that you guys will be working on this afternoon is the Miller-Spencer model, 1977. So it's kind of, I came back and reread this model when we went to work for the Brits on Brexit. I suddenly was fascinated to go back and look at what the policy debates, the echo of the debate in 77 about joining the EU and the debate about leaving the EU. It's amazing how many similar sorts of issues arose in the two frameworks. And it's really fascinating. And these guys did a very nice job. I should say the Miller-Spencer model is also one of these things. There was a young graduate student who worked for Hubbard Skypes. Terry Lensberg was a Norwegian guy. I know Terry because I worked at the Norwegian School of Economics for a couple of years. And also he was the advisor to my advisor when I was there was Lars Mathieson, and most of the tools we're using are Lars Mathieson's ideas. And so in fact, what we're learning this week goes directly back to this paper. So this paper was motivated by the ability of Terry Lensberg to do the work for them on the computational work, because these guys were very good policy economists, but they didn't know much about computation, or at least that's my understanding. And Lensberg did a lot of the work, and he basically came exactly the same chapter that we're using. So it's kind of fun. So this was, the Miller-Spencer model was the standard Armington trade model. So standard neoclassical, multi-sector, multi-regional, constant recurrence to scale, perfect competition, gains from specialization, as internet industry trade to do differences in comparative advantage and preferences. So preferences across the variety. And there's endogenous terms of trade. So there's scope to attract rents from strategic trade policies, tariffs, quotas, and NTBs. But it's also prone to the Harper constant. So that means that the welfare costs, you can kick this model as hard as you want. It'll always give you solutions. You can solve very large dimensional cases, but you know the results are always going to be relatively modest. So there's relatively small welfare gains. The cost of interventions are small, and the gains from liberalization are going to be small. So it gets a lot of it gets discredited, and this is, I'd say, the neoclassical approach to trade has a number of reasons to be skeptical about it. I mean, there's this tendency to sort of recognize, if we look at the development experience of the past 20, 30 years, the countries that didn't follow the Washington consensus were the ones that were most successful. So it's clear that the neoclassical paradigm, which favors laissez-faire, is definitely worth questioning whether this is right. The question is, what do we gain, or what are we losing if we throw out the neoclassical paradigm? What do we do? What do we use in its place? And that's the challenge. The problem, the advantage of the neoclassical approach is it's very versatile. You can take into account different aspects that may be ignored: risk and uncertainty, technology expectations. It can be calibrated and estimated, so it basically is possible to come up with a model that's operational relatively quickly, and then you can basically do a more empirical work. And a lot of the quantitative international trade theory, which is based on models which purport to be different, but which are not very different from traditional CG models. That's their main thing, is that they can estimate some coefficients, and the approach can be consistent with the principle of Occam's razor. Like, you want as simple a possible model with no simpler, but it's important to bear in mind that modesty is warranted. The existence of model results should be considered more of a necessary rather than sufficient condition for justification of a policy proposal. In other words, if you're going to tell me that there's a policy you think it makes sense, show me a model where that makes sense, and then I'll listen to you. But if you don't have any model to show that it makes sense, then the challenge is that this process, and that's what you learn from listening to Jim. Jim's a master at this process of taking the story and then write down the model. This goes back to this Larson cartoon of Hell's Library, where the books on the shelf in Hell's Library are story problems, more story problems. So translating words and ideas into equations is where the big challenge comes in. So there's a big desire for extending the standard model and want to incorporate sort of new trade theory, sort of industrial organization trade. And the key idea of Krugman is that trade increases varieties. So this idea is this Dixit-Stiglitz framework that Jim talked about this morning. It gives you an increase in returns to scale. There's imperfect competition. You can't have scale economies without having some other story about competition. And what we're attempting to do in this BRF model was something we grew out of our Brexit work, is that we had a challenge is that Ed Balistreri and I had already written a paper about the Melitz model and showed how to do this in the GTAP framework, but we couldn't handle the dimensionality that was demanded by the Brits because they wanted to go down to the tariff line, and they always wanted all the GTAP sectors and then some. And the problem was we couldn't really do if you stay in the CRTS paradigm, you can put in lots of sectors, but then you're prone to always be getting back these very small numbers. And so there's this interest in, can we get an alternative perspective that gives you something similar to that has the idea of the extensive margin of trade and has variety effects in it without having to give away lots of sectors. So that was our challenge here. And we also had this interest in representing foreign direct investment. So we wanted to capture a model where we actually capture the fact that, I mean, just ridiculously large, I used a diagram here, I don't have the infographic, but you look at the amount of GDP that's generated in the city of London and the banking sector, it's just enormous. And that's a lot of that is FDI. And things that disrupt that have a potential huge welfare effect. But if we've calibrated the CRTS model, we're not going to get any of that because the mobility of the foreign direct investment response is not going to perform. So in this paper, we talk about three models: the Armington model, the Krugman model, and the BRF model. And this is so the Armington model is, you've seen that up close. The exercise, you get to work on it some more this afternoon. Krugman is this basic imperfect competition model where you keep track of the number of varieties in addition to what the output is. And Jim talked about a Krugman style model this morning. So that, and you also have this Dixit-Stiglitz variety of led growth. So you have additional things. The key simplifying assumption in the Krugman model is all varieties are sold in all regions. So as soon as a variety shows up, everybody gets it. The BRF model tries to capture that the number of varieties in the country may not all be available here. So the number of varieties that from country I that tend to sell in country J will be endogenous. So that gives you another margin of trade that as you liberalization or protection tends to affect the number of varieties that come in. And so you get bilateral interventions tend to affect what the overall welfare gains are. So BRF incorporates the Dixit variety effect, but unlike Krugman, not all varieties from region R are sold in every region S. So in this standard model, the idea is that, and I like to think about this as Armington composite. So the standard Armington model, we just worry about aggregate quantities. We use typically Harburger units. So the Q's are how many dollars of expenditure you have in the base year, and there's going to be a set of shares, and we have 1 degree of freedom in this framework. That's going to be elasticity substitution, and that gives us this setting where we can minimize the cost of providing 1 unit of output. It's constant returns to scale function, so you just minimize the cost of producing 1 unit, and that tells you the optimal policy for any number. When you have a Dixit-Stiglitz effect and you assume symmetry across varieties, so each of the I's are different. Good, so we have a number of, if we have a number of firms just N sub R, and we're going to have X sub IR is the amount that we consume from the ith firm, then and you assume symmetry of that, then you get this formula where N is the number of firms operating in region R, sigma is the elasticity differentiation, X is going to be the sort of aggregate resource value of the output, which is the number of firms times output per firm. And then you have this overall effect of the number of varieties N, which will be through the Dixit-Stiglitz effect, gives you a scale effect. I like to tell the story. It's like I have this. The most compelling explanation of the Dixit-Stiglitz effect for me was in the Peace Corps. I built bridges for a couple of years, and I had to, it's in South Asia, major challenge finding fasteners. You could have any fastener you want as long as it's a 13 millimeter, nut. There were very few different types of fasteners. And I came back and took a job as an engineer in the US. And the first time I had to do a little design problem with redesigning some mechanical device, and I had to design thing. I said, well, what fasteners can I couldn't believe it. The fastener catalog was like 8 inches wide. It was so big, you had like huge numbers. So that's the idea here, is that basically, if you have more varieties, that makes life better, because you can buy something that's more closer to what your variety is. So this is the BRF framework. It's going to be like a Krugman model. These are differentiated, but not all goods from region R are sold in all regions S. So we have this in the Krugman model. We have N sub R as the number in region R, and that affects all consumers. Whereas here we have not all varieties will come across on a given bilateral trade link. So there's this, the protection tends to affect, and it's consistent with the empirical evidence that in trade, the more efficient firms tend to be more engaged in exports. So you tend to have this effect of buying these guys off. We're going about 10 minutes left.
I gotta go in like 1 minute,
Okay.
but you can keep going. I think this is great. I think everybody's probably interested in hearing about this. Why?
Yeah, no, that's fine. That's fine. I'm game too.
Yeah, if you could just keep going, but I gotta jump off. By the way, never mind. I was gonna say that idea that more productive firms export. Who wrote that? Is that like
That's
a Jensen?
That's empirical. Yeah,
Yeah,
Jensen. had a paper
Jensen.
with this.
Yeah, right. Okay. Yeah, that's just clicking on it. That's all.
So the other thing is in this framework is we can capture this idea of foreign direct investment. So we have this FDI you have the cross-border provision of services, and you also have domestic commercial presence. So that's in this framework, we can capture both of these. This was put in the model so we could incorporate what happens in the finance sector. And it matters a lot. So in terms of the cost of Brexit, it goes up by 40% when incorporated FDI. So cross-border depends on service inputs and foreign direct FDI capital, and this gives us this fundamental sort of extensive margin of trade. So exports are going to depend on you have to basically set up supply routes, shipping. So there's basically some investment that's required to get onto export, and that the cost of providing there's basically it becomes congested. So you get a supply curve for the number of firms that tend to come in. So it's important to think about other ways that you might try to capture reduced form productivity effects. And this was early on in our work with the Brits. We talked about doing this. They just wanted to capture this idea that aggregate productivity tends to increase with trade. And so this was an example we looked at early on. I'm just pointing this up as sort of a straw man for explaining how this actually works. So aggregate productivity effects here. So here we have WTO. So that's going to be if UK were to drop all its bilateral trade agreements and go to WTO, fall back on its bound tariffs, we can see that with total factor productivity losses, magnitude of losses fall from 2% to like 11% or 14% of GDP. So there's a much bigger productivity effects. But the impacts, these kickers are fragile and depends on the implementation, details of the implementation. So here we have I forget now how this works. So we had, if you had different ways that you can basically, what the structural representation is between trade flows and productivity has a big effect on how this works. And because there's no sort of underlying, this is all reduced form representation, we see that the difference between the brown line and the gray line show that we don't really, this was two different plausible ways of implementing these sectoral productivity effects. So therefore, basically the view is that the fact is you want to build a model that has bigger effects from trade liberalization or bigger costs, and you have to be careful about doing this in an ad hoc manner. But the fact that it makes sense to look at a structural model that has something other than CRTS, that was pretty evident. This goes back to 2008. This was work that I did on David Tarr, assessing the distributional effects of WTO accession by Russia. At the time, when we were doing this analysis, we wanted to get household level data to get a little bit, get a sense about the distributional consequences of trade. And it was this interesting challenge because the guys at Gus Comstat, I guess the name has changed now, but at that time it was called Gus Comstat. It was the sort of statistical arm of the Russian government, had a number of surveys and so forth. Lots of data. At 55,098 households in the sample data set, because they told us they were willing to give us the data set as long as our model used every single piece of data. So we were only allowed to take the data if we built a model that had all the sectors. So this shows the effects between what we call our central model, which is something similar to the BRF framework, where we had a gain from WTO accession of around 7% and virtually no losers in that framework, versus the CRTS model, where the average gain was much smaller, around 1%, and we had a large fraction between, the percentile gains were, there was about 15–20% of the population where the welfare effects were negative. So this is just pointing out that the structural framework really matters. And it's not to say that one is necessarily better than the other, but it's also good to know what the range of impacts are in different settings. So in the current paper, we just wanted to illustrate how this works. So we have a model where this is sort of illustrative of the type of model for which you can get results back relatively concisely. It's a relatively smaller framework within the Brexit the Brexit analysis group. They developed a version of this model that had all the sectors in it, but for the purpose of this paper, we did a relatively compact version. So we have these 8 regions or so, and 2 CRTS goods, and 7 IRTS goods. Services had FDI, and then we have the factors, and these are the factors of production, the labor categories that are in the GCAP database. So we look at, what are the import tariffs? This is as of 2018. What were the various trade interventions that were on the table? So we have import tariffs, largely on iron and steel, a few on other manufacturers. Tend to be more heavy taxes on China, and then taxes on U.S. exports. Again, this is more recent. Again, I'm kind of looking at this thinking, boy, it'd be kind of interesting to go back and see what the current state of affairs is on these tariffs. I mean, now I guess a number of these have been passed, to be asking the question of what did the model predict based on the benchmark in the year in which they were brought in, and how does that compare? Could we do some sort of backcasting to identify what elasticities are? It does take time for it to respond. So you see the overall welfare effects here, and this is for 3 different models for each of the regions in the framework. So we have the BRF model, the bilateral representative frames models. This is welfare in terms of equivalent variation in billions of dollars. So the global results are on the right there, and you can see that the Krugman model and the Armington model don't really produce. There can be big differences, but they don't really differ that much, and they both are much smaller. Whereas the BRF model, the US is sort of the center of the storm. It has the biggest losses. But there's basically the structural effect of the model really matters a lot for capturing what goes on. Welfare impacts across model structures, then there's benchmark GDP, consumption, equivalent variation in terms of dollars, billions, and in terms of equivalent variation in percent. And again, here we see that BRF is like loss of 0.5%, Armington is around 0.1%. And China and the US both lose from this on the order of 0.5% in the central model. And the spillover effects are not all that large, actually, in this setting, in any of the settings. US output impacts from the reservation, largely the biggest loser in this is agriculture, which is consistent with what we observed. And then the gainers are those that get tariff protection from the east, are the ones that going forward. And impacts by sectors in terms of dollars. There's always this overall effect on services. Services, a large fraction of the US economy. It's not directly threatened by by interventions, but the reduction in trade reduces the demand for international trade services, and other service sectors tend to be affected as well by loss of export markets. So those overall output effects. So if we decompose what the effects are in terms of across, we can do a decomposition of real GDP effects according to an expenditure basis or across a sectoral basis. If I look at the last column on the right, that's the percentage change. See that the overall effect is largely the biggest losses are in agriculture. The overall sort of gains come about through the movement of the competitive advantages conveyed to machines and equipment and steel. And there's a loss as well in other effects. So this shows the overall range of effects. And also you can look at this adding up what the trades are, what the effects are across sectors. And again, we see this effects. And again, what we're interested in doing is adding this layer. What we get with the WinDC GTAP framework is that we have an additional dimension where we can look on a map and see what the distribution is based on distribution of sectoral activity and regional trade impacts. We can look at the effects across the country. So kind of an interesting sort of exercise to do. Again, looking at which sectors are affected or which the effects. This is looking at sort of a sensitivity. If we look at a 20% non-tariff barrier on the US exports, to be honest, I can't remember, the Brazil and Argentina. So this is modeling as a subsidy. To be honest, I can't remember the details of this paper. This was this food security scenarios. I can't remember exactly what this was. The basic sort of finding was the China's food security things tended to, China turned around and basically tried to prevent US soybean exports and to pivot toward importing more from Brazil. And so there's an overall effect. Brazil in the, again, it depends on in the agricultural sector, Brazil gains enormously from this, the US loses, so there's a redistribution. And the overall effect here is, this is output. So that's going to be the imposition of protection on imports from the US tends to raise output in China. And finally, we do an experiment. We say, suppose we put in a bilateral tax on Chinese imports to trade, to have move toward balanced trade. And here we see there's a huge loss. So the thing is that the non-tariff barrier. So if you basically put in a non-tariff barrier to require that have bilateral trade balance, this is extremely costly. Even a tariff is costly. So basically, the idea that you on a bilateral basis are going to impose trade balance, this is really costly. So the key overview from this debate, I'm welcoming the opportunity to get this paper out again because I hadn't looked at this in a while. But so disruptive policies are a very high cost approach to non-economic objectives. Food security, financial dependence, all these things. This is a really costly way to go at this. It's structural sensitivity matters a lot, so there's not going to be one estimate, but you get a range of effects across different models. And the other thing is looking back on this analysis, at the time we thought it was going to become apparent that these policies were extremely costly, but there's so much other chaos going on at the same time that it's always, whether you're doing it ex ante or ex post, you still have to have a model. The fact that you do it ex post, you still are trying to sort out what the effects are of this particular intervention. So I think that's kind of an interesting story. Of course, the new quantitative trade analysis emphasizes the structural estimation of underlying elasticities. And we have this sort of natural experiment now of all these tariffs have been imposed. It might be interesting to think about trying to assess what's happened to trade over the last 2 or 3 years and see if we could use those to estimate what the net contribution was of these policies. Anyway, so that's sort of a motivation for where we're going tomorrow. And the idea is tomorrow we're going to basically focus primarily on the bilateral sort of border carbon adjustments. And I'm going to begin in the morning by going through the GTAP framework, so the structure of the GTAP model. And then we'll look at the combined model, and I'll bring along a few more exercises we do tomorrow with the actual model. So tomorrow I'd like to move more toward, less about building models, more about running models. So we're going to have a framework we can look at and learn a little bit. I've not had time. I did actually update the M3.pdf. The slides I did put together on how to collect output from a GAMS model and to visualize it. That's for a small model. I updated that PDF file, and that should be posted, so you have some example. But tomorrow we'll talk a little bit more about this mechanics of how to work with a model where you have a large number of sectors, and you basically, there's a few tricks that are helpful for how to work with these databases where you produce output files that are bigger than you can handle in one Excel sheet. And it's helpful to know about how to use the Excel data model. And so, although it's very possible that you guys know this already, but it's something I've learned in the last year, so I'm always keen to tell people. So that's what I've got going. I'm open to questions or feedback.
One question. So
Yeah.
the three models you talked about, the Arlington and the Kruger and the last one, BRF or BRF.
Farmington, Krugman, and BRF.
Yeah. You have very divergent results.
Well, no, I'd say that qualitatively they're similar, just the magnitude of the impacts. So these are all different. So if I look at the magnitude of the impacts across these guys, so this has got welfare impacts, BRF, Krugman. So it's a matter of, you can get a factor of 4 difference for the US.
Yeah.
And for the other one, so there are a few where the sign is different, so that the Krugman model and the Arlington model are different for China. So in the Arlington model, so there can be some differences. But the fact that we get difference in results, I think that my own view is that the CRTS model, the construct terms of scale model, which has been the workhorse of trade policy, it really doesn't have much empirical foundations. It's compelling as a story, but in terms of what we've observed in terms of growth experiences over the last 20 years, there's no way that the Arlington model can explain what's happened in China in the last 30 years. There's just no explanation. So I think that my own take is that it's time to look for frameworks that have a wider range of possible stories about what drives gains from trade. That the standard sort of comparative advantage story that we've relied on, it seems like it's an easy story to tell, but it doesn't have that much. It doesn't really line up with what we observe. And I just think that the downside is that we then move from a model where the laissez-faire is going to be optimal to one where there can be sort of government involvement can actually improve outcomes. So it can be strategic. So I think this is where it's certainly where the theory is going toward models that account for something other than just a standard CRTS setting. The CRTS model for computational work, it's still going to play a central role, because for data sort of getting up a benchmark data set together and making sense, you always can solve the CRTS model. Very easy to set up. We know that the model will be set up. But I think this shows that it's always also important to think about other ways that you can represent the same effects. So yes, we can declare victory.
Yeah.
Okay, so
Back at 3:30.
to be back at 3:30. This is an opportunity for those of you who want to do work on the computational exercise. This is an opportunity to do that and then come back with questions. So 3:30. Our objective is to be done by about 4.